So this is 7-2. It says up there. We're doing similar polygons. Similar polygons have the same shape but not necessarily the same sides. And two polygons are similar if and only if the corresponding angles are congruent and corresponding side lengths are proportional. So we have two polygons, ABC. D is similar to WXYZ. And from the picture, I already wrote out that the angles are all equal, like A is equal to W, B is equal to X. And if you look at the two sets of polygon writings, like A, that A is right there, oh my gosh, is equal to W, and B is equal to X, C is equal to Y, and D is equal to Z. That's pretty easy to see, but the fun part is we have a bunch of proportions from these, like AB divided by WX is proportional or equal to BC divided by XY, which is equal to the next sides, YZ, not that, CD divided by YZ, which is also equal to AD divided by WZ, which we can do, for instance, though, so those are all equal. So if we have AD is 18, or I guess I start AB is 15, divided by WX, which is 5, that means all the scale factors are 3 divided by 1, or just 3. So that creates a lot of fun scenarios. For instance, we have an example. List all pairs of congruent angles in right proportions that relates to the corresponding sides. So hopefully you can do the angles pretty easily. All you do, take each part. So we have angle F is equal to, well, it's congruent, but there's no congruent button on the computer, is J. Angle G is equal to angle K, and angle H is congruent to angle L. That was easy enough. And right proportion that relates to the corresponding sides. So now we do the sides. So we just go through the triangle 2 firsts divided by the second triangle's 2 firsts. So FG and JK is equal to the last, so GH divided by KL, which is also equal to the first and last, or again, if you look at the picture, it just matches up. FH divided by JL. And that was a fun problem. Let's do more. So we have a cute puppy. Kuma wants to use a rectangular photo shown as the background for her computer, but she needs to resize it. Determine whether the following rectangular images are similar. If so, write the similarity statements and scale factor. So to start off, we have to figure out if really we could write the similarity, but we need to figure out the scale factor. So we take it. So if this would work, we would have BC equal to FG or KL. They're all 12, so we can kind of assume that they're all going to be the same. 8 divided by 12 is equal to 2/3. No, it's not writing. It'll be over here now. 8, nope. They're equal to 2/3. This is just great. So really the only problem is going to be the bottom part, and it just appeared. So DC would be equal to the bottom, either 15 or 14. One of those will be 2/3. If it's not 2/3, then it's not actually similar or proportional. So we would have 10 divided by 14, or 10 over 15. This is just lovely. You do those similarity statements, and you know that 10 over 14 isn't 2 over 5, or 2 over 3, but 10 over 15, that's not what you're supposed to be doing. 10 over 15 would equal 2/3. So the picture B is correct, and I'm going to type out those similarity statements down here. That would mean that polygon ABCD is similar, which is this little squiggle, it's called a tilde, is equal to JKLM. And that's essentially how you do those with the scale factor of 2 divided by 3, or 2/3. Moving on to more fun. We have two diagrams. ACDF is similar to VWYZ. We have to find x. To find x, we have to figure out the scale factor. And I know that you would think that AF would be similar to YW, but if you look at the parts over here, AF are the first and last parts, when VZ are the first and last parts in the other one, which would be this side and this side. So that wouldn't work. So you actually have to do CD, the middle two parts, is equal or proportional to YW. So you would have 9 over 6, reduce it to 3 over 2. So the top triangle is the top part, which would be, in this case, x over 10 would be equal to 9 over 6. And would have to solve that. And there's other ways you could do it, but I'm going to cross multiply and get 6x equals 90. Solve for x, divide by 6. You should get x equal to 15. That was amazing. I want you to try y. I'm sure you did a great job. Good job. On to the last little bit. This is our first theorem of the chapter. Perimeters of similar polygons. If two polygons are similar, then their perimeters are proportional to the scale factor between them. What that means is, and I'm going to kind of cheat, I'm going to go down here to this part. So if you take the perimeter of the bigger triangle divided by the perimeter of the other triangle, it'll actually equal, let's say, AB divided by JK. And all the other sides, BC to JL, LM to DC, and AD to JM. So that's a cool little fact, and we're going to use it in the next example. And again, if you need to pause things, do so and take notes on this because it's important. So we have these polygons, and I'm going to start it off, and you're going to finish it for class. We have, first of all, we look at the pictures. We know that 1 dash means that their sides are similar, so we know there's secretly an 8 up here and a 4 down here. Also, we know that there's a 3 over here. We can't figure out the other numbers, but we actually can. If we know that this bottom right part here is 4 and this is 3, they're supposed to match up. So the scale factor is going to be 4/3, and the 4 will just randomly show up because I don't understand. There it is. So it's 4/3. So if we know that the scale factor is 4/3, we can take 4/3. Let's just say this is x, RQ, and that matches up with 8 over here. So that'll equal 8 because it's in the top, so we keep both the tops together. X, and solve for x, and you should get x equal to 6. So that's 6, and I think that's a race. Nope, that didn't work at all. So this x will become 6. I want you to figure out what ST is, and then find the perimeter of each polygon. We will go over this in class tomorrow. I hope you had fun. Goodbye.